Hello, class. This is Mr. Hart. And in this podcast, we want to finish up the pressure unit and talk about Bernoulli's principle. Now, you may have heard of this principle before, so we're just going to jump right into it and talk about how it relates to fluid flow. But it basically says this, okay? The pressure of a fluid drops as its velocity increases. The faster the fluid is flowing, the more its pressure will go down. You can think of that simply being the fact that it can't interact with objects as easily because it's moving a lot faster. Okay, if you have a surface and a particle is moving really slowly, right, it can hit into that surface a whole lot of times as it goes. But if it's moving faster, it will have less interactions as it moves along the surface. So just in general, more velocity means less pressure. Okay, so most common application we'll see, and you probably already know already, is with airplanes. Okay. So this is a picture of an airplane wing from the side, okay? And we can see that in this illustration, right, we have this air that's flowing across this airplane, and because of the curve of the airplane wing, the way it's set up, this air needs to get to the same spot as this air at the same time. They kind of want to meet up right here, if they can, because of fluid flow. And so the air at the top kind of bunches together. Okay, and as we learned from last time, that means its velocity is going to increase. Okay, so we got fast moving air up here, slower moving air down here. Well, that's going to cause a lower pressure to occur on top and a higher pressure to occur on bottom compared to each other. And as we've learned from previous lessons as well, high pressure always flows towards lower pressure. So that's going to push up on the wing and cause the airplane to lift. But all that's done simply by changing the velocities of the two air pressure, or the two airflows going above and below the wing, which causes different air pressures. Okay, so that's the most common and practical example of Bernoulli's principle. But there's other things that people see. There's a common demonstration that you've probably seen in your 8th grade science classroom, where they take a hair dryer. Okay, that's a hair dryer. Anyways, they'll take something like a golf ball or a ping pong ball, and they'll put it right here, and they'll turn on the hair dryer, and you would think that the hair dryer would just blow the ping pong ball away and it would disappear and all this stuff. Okay, but what really happens is you get the hair dryer going, and there's this airflow coming out of the hair dryer, and as it moves around the ping pong ball, okay, it causes a low air pressure spot to occur right where the ping pong ball is, because the air is moving really fast. And so the higher pressures on the outside push in on that air pressure, right? And so we get this kind of trap that occurs. So the ping pong will stay there. So even if they point the hair dryer at different angles, the ping pong ball will stay there because it generates this pressure trap because of the fast moving air of the hair dryer. Okay. So that's another fun example to see. Here's another example with what's called a Bernoulli bag. This is a video of me demonstrating it. So as you can see, if you just blow straight into the Bernoulli bag, it doesn't give you a whole lot of air. It doesn't trap a whole lot. But if instead you pull back and blow away from the Bernoulli bag, then suddenly you get a whole lot of air into it. So why is that? Why does that work? Well, that has to do, again, with Bernoulli's principle. So here's a drawing of what's occurring. So if instead of blowing into the bag directly, you kind of blow a little bit back, you can cause a low air pressure trap to occur right here where you're blowing because you have fast-moving air, and that causes the high-pressure air on the outside to move in, right? So when you blow into the bag far away, you're not blowing a lot of air into it, but the high pressure air around will come in and fill up this whole bag right here because you got the pressure from the outside coming in to fill it. Okay, so cool stuff. Another example to be wary of, this is actually kind of applicable if you live anywhere near trains. Okay, a common thing that occurs is when a train comes by, it's pushing a lot of air in front of it. Okay, so if you got a train and it's going this way, they always tell people that if there's a collision that's about to occur with the train, you want to move towards the train instead of away from it, which is true because of the collision. But make sure you're also moving out to the side as much as possible. And here's the reason why. When that train is moving forward, right, this is an aerial view, it's moving in this direction, okay, that's going to create a low pressure. So if you're sitting outside right here looking at the train as it goes by, that train is going to cause a pocket of air, right, this low pressure pocket to occur, which means that high pressure air from the outside of the train is going to pull in. Okay, so if you're too close to that train, guess what's going to happen? That high pressure air is also going to push on you and move you towards the train. Okay, so even if you're not super close to the train, you got to be careful. You don't want the high pressure air pushing you into its track as it goes by. Okay, so if a train ever is going, right, and there's about to be a collision or something and there's going to be a whole bunch of debris, yes, you want to run this way because you don't want the collision to cause debris to go in your direction, but you also want to move out if possible because you don't want the high pressure air pulling you into the train. Okay, so just some things to think about. If you're ever in that scenario, let me know. I want to know what happened. Okay, a couple of other examples is if you ever run through the hallway, sometimes you'll notice that the posters in the hallway kind of flow in the wind, I guess you could say. So like if here's the wall, and I'll see if I can do perspective on this. You got a poster kind of sitting on the wall and it's taped right here. Sometimes the underside of the poster will like flap in the wind a little bit. Okay, it'll kind of go up like this. That comes because of, again, as you're running by in the hallway, right, here's you running through the hallway going that way, you cause a low pressure point in front of you. Well, what's going to happen is the high pressure air near the wall is going to go towards the low pressure air that you are causing and cause the things to flap as you go nearby. So even someone that's big as you, right, or small as you, I should say, you're not a train, even you running fast can cause a slight low pressure pocket of air to occur, okay, which can cause hallway posters to flap and things like that. Okay, one last example I want you to think about. I don't know about you, but there's a turn by my house that I'm waiting to turn left to get to the street where I live on, and I'm kind of just sitting in the road like this in the middle lane. Let me see if I can draw this properly. So here's the left-hand turn lane I'm sitting in. Okay, there's cars going this way, right, and there's cars going this way. And when I sit in that left-hand turn lane and those cars go by me at about 45 miles per hour, I can feel it. My car starts to shake back and forth. Again, for the same reason, there's a low pressure point that occurs in front of these cars as they're going past me. The high pressure by the side of my car, I guess I would put it over here, starts to push on my car trying to get to that low pressure. So as those cars pass you can feel your car shake back and forth because of the airflow that occurred. So even cars passing can cause low pressure points, low pressure traps, and cause air to flow back and forth. Okay, so you'll see this a lot more often than you think. So be aware of it. Think of things that are moving fast and see if you can see those pressures that are occurring. Okay, but lots of cool stuff. Your homework is actually a little home lab where you'll do some of these types of experiments on your own. But hopefully this all made sense. Let me know if you have any questions, and thank you for watching.